Welcome to this demonstration of how to connect a Red5 controller to the IoT using UDMI schema. This uses MQTT to publish data to a cloud-hosted data lake for consumption by backend systems that are not part of this presentation. We can also use UDMI schema to allow for cloud write-back so that backend systems can be used for agentic AI and other automated processes. First, I will connect to my IntelliCloud instance to show the Red5 controller that I will configure for UDMI schema. I will use this Warn VAV101, which is a Red5 Edge V440 controller. But we can use any Red5 controller, any eBus2 controller, or an O3 Edge controller. The only requirement is that you must be using V413 or later firmware. Here is the device in IntelliCloud. It has some objects in it, so we have some data to publish. For ease, I am going to use a generic Mosquito MQTT broker, but this could be any broker or bridge. The module supports ClearBlade IoT, which is a clone of the deprecated GCP IoT Core, AWS IoT Core, Azure IoT Hub, or just a generic broker such as Mosquito, as we are using here. UDMI schema provides a protocol for connecting a device, and then the configuration of what the device publishes to the cloud is held in the broker. This is a huge advantage over other methods, which rely on the device being configured somehow so it knows what data to publish. The key advantage is that the device is managed from the cloud, reducing the number of visits to site to add or remove a point from the point set that is being published, or change the interval, or whatever. Other IoT layers usually have another independent data layer, which just adds cost and complexity to a project and locks the client to that particular MSI because the MQTT payloads are bespoke and only they can change them. UDMI schema has been called the open protocol for smart buildings, and that is a very true statement. We will use a readily available MQTT tool so that we can see and control the cloud side. I'm using MQTT Explorer. There are others, MQTT-X, for example. It's a free download and works well. Here is the interface. First, I need to connect, so I just add the IP address or URL, check the port number. This broker has no authentication. Others may have usernames and passwords, and/or certificates and keys or tokens. The UDMI module supports these as well, but for the sake of brevity, we will not use any authentication here. So here is the view of the broker, and you can see that there are already some topics and some other data being published to it. Remember what I said about UDMI schema managing the device telemetry from the cloud side? So when a UDMI device connects, it subscribes to a specific topic, as defined by UDMI called the config. This tells the device what to publish and when and whether it needs to act as a proxy for other non-UDMI devices on the network. So we need to put the appropriate message into the broker so that when the device subscribes, it gets sent down and the device knows what it needs to do. We can do this by publishing to the topic from MQTT Explorer and making sure we have set the retain flag. Then whenever something subscribes to that topic, the broker publishes that retained message. I will do this now. The default topic prefix for UDMI is site reference /devices/device name. Then we add config to that and put the relevant data in the message payload. This is what the data looks like. A JSON block that is defined by UDMI, you can see an example here. A version number for the UDMI schema being used, a time and date stamp in ISO 8601 format, and then the points that are to be published in what is known as the point set. Note that each point is in its own block and they are individually named. The ref field gives the backnet reference to the property of interest, and if appropriate, a units field is supplied. So we have the JSON payload. It is usually a good idea to run this through a JSON format checker, as I have done here, just to make sure all the curly braces and commas are correct. JSON is pernickety. Then I will paste it into MQTT Explorer, set the QoS to 1, make sure the retain flag is set, and publish. Now the payload is in the broker, waiting for someone or something to subscribe. Okay, that's the cloud side setup. You can imagine for a large site, this is quite a piece of work to do. Normally, this is done by the MSI using data supplied by the SI about what devices and points are available. The MSI uses this to create the metadata and populates the cloud side, often using IoT tools that they have created to verify and upload the data automatically. We will now jump back to IntelliCloud and set up the device to connect to the broker. First, we need to load the UDMI module into the device. This is a loadable module as supported by our v413 and later devices. Create a FIL object. The instance number doesn't matter, but the name does. Name it UDMI gateway.dlm. Pay attention to the capitalization for this and all other objects we create here. Upload the DLM file into it and wait for up to a minute for the controller to detect it, verify it, and unpack it. You will see this in the description property window, top right on the FIL object page. So we can check that the module is running, create another FIL object named Google IoT Gateway. Again, the instance number doesn't matter. Then wait for a bit and you should see some text in the description property window giving the version, start time, etc. Now, we just need to configure the device to connect to our cloud IoT platform. To do this, create a CSV object of any instance number and named Google Cloud IoT Gateway Configuration. I'll just check the DLM page. Looks like it hasn't loaded it yet, so I'll give it a bit longer. We need to set the value of the configuration object to be a JSON block that defines the connection parameters. This and a lot of other information is contained in the setup guide. But here is a JSON block that I have prepared earlier, giving the URL for the MQTT broker, the port, the device name, and a few other parameters. So I will just copy and paste that into the default field for the CSV object, which the UDMI module will read, and then try to establish a connection. If we flip back to the DLM page, we can see that the controller is loading the UDMI module. Once loaded, it automatically starts, which we can see here. Now, if we go to the configuration CSV page, we can see in the description window some status information to see something is happening. And you can see that we have connected, we have received the config topic, and now the device is publishing messages to the cloud. If we go back to MQTT Explorer, we can now see the messages. There is state, which will show any errors. Event system, which shows the status of the device. An events point set, which contains the telemetry from the objects been published to the cloud. That's it for UDMI then. Most of the work is in setting up the cloud side. The actual device configuration is very quick and easy. One other thing that UDMI supports is the concept of write-back. So we can add a term to the config message for any points that we want to write to that point. We do this using the term setValue and then providing a number to write, or if it is binary, active or inactive as the value in the JSON key value pair. Now, when I publish this, you will see that the relevant point is written to with a priority of 7, which can be changed.